Hi, let's talk about the second question, which is minimum depth of binary tree, right? So if you have not checked out the similar question, maximum depth of a binary tree, I would strongly advise you all that please make sure you look at that video and we then come back here, because then this question is basically kind of a second part to that question. All right. So in this question, the question is given a binary tree, find its minimum depth. The minimum depth of the is a number of nodes along the shortest path from the root node down to the nearest leaf node, right? A leaf node is a node with no children. So as like the previous example, we know how to read this tree, correct, which is given to us, right? And we suppose here it's also told us that the depth is basically calculated in terms of number of nodes, right? So we know what depth needs to be given in what terms, right? So here if you see from the root node, what is the minimum number of nodes until I reach a leaf node? So from 3 to 9, 9 is a leaf node. How many nodes you have? 2. From 3 to 15, how many nodes you have? 3, 20 and 15, 3 nodes. 3 to 7, again 3 nodes. So the minimum among them is what? The number 2, because 3 to 9 you have this 2, and that will be your answer, correct? Now this question is very similar to the maximum depth question, correct? I hope you all agree with that, right? So let's just, so now if I have to look at the code, what will be your first guess? Most of you will tell me whatever code we have written for maximum depth, wherever the value was 1 plus max of, left comma right, we instead of doing maximum, we'll now find minimum. Yes or no? That will be your first guess. Let's try to just check whether it works for all situations. Okay. So we have a tree here. There is a tree. Let's put some data in this. So let's say, let's take a black color, right? So here I have 3, okay, 9, then you have 20, you have 15, and you have 7. Let's draw another tree here where we have 3, 20, okay, 15, and 7. So let's go by the, wherever 1 plus maximum of whatever in the left and whatever in the right. So sorry, instead of maximum, now we are going to go look for minimum, because we are interested in finding the minimum depth of the tree. So 1 plus minimum. So our guess is in that maximum depth question, if I just change the line, basically just change a word from maximum to minimum, I should be able to get my answer. So let's see what we are getting here. So if you look at this particular node is going to return what? A value 1, correct? Because how many nodes are there? 1 node is there. What about this? Now you start from this root node, right? First it goes to this left child, right? You finish this, then you come here. This will again go to its left child. Now this is going to return what? 1 for this, right? This is going to return 1 here. So 1 returned here, 1 returned here. Yes, you're taking at 1 plus minimum of left comma right. So 1 plus minimum of 1 comma 1 is basically 1. So 1 plus 1 is going to give you what? 2, right? So let's so this is going to give you 2. Okay, so let's do one thing. This 2 value will be returned back here. Okay, I'm just keeping this as it is. What is this going to give you? This is now root value is here. At root also you're going to apply the formula 1, because you have to count the root node, right? 3. 1 plus minimum of 1 plus 2 is nothing but 1 plus 1, which is equal to 2, and that was actually the answer for our question as well. So here you will see the minimum depth of this tree is 2, and it worked, right? Just by changing that line worked. Let's try to use the same formula for the second example, right? If you come up with a formula or logic of question, it should work for all the test cases. Most of the time I have seen students coming up to me and saying that yes, they solve a question. What happens is whatever logic they apply, it does solve, it kind of works for these sample inputs, okay? But when they try to submit, now when you submit, actually more, not just these 2 examples, but a lot of test cases are going to run, correct, which are going to fit into these constraints. So when you say your logic or whatever problem you have solved is correct, it should mean that your problem should be able to solve correctly, okay, for all the different test cases, correct? That means whatever logic we have applied, if it is correct, it should also solve for this tree, okay? So let's try to do that. Here, what is this going to return to you? There is no nodes here, right? Because this is null. So this is going to return what? 0. Yes. What about this? This is now start from root. Left was 0. So this is your root. Okay. Now this is going to call the left child. This is going to return 1. This is also going to return 1. So you're going to return back 1, 1. Right? You're applying the same formula, 1 plus minimum of 1 comma 1. So you're going to get 1 plus 1, which is equal to 2. You're returning this value to your parent. Now look at this for the root number 3, for the tree 2. What is the formula you're going to use? 1 plus minimum of 0 comma 2. What is 1 plus minimum of, 0 comma 2? 1 plus 0. What is this? 1. Is this the correct height of the tree? No. The correct height of this tree, I mean the minimum depth of this tree should be basically 3 and not 2. Why? Because according to the question, the minimum depth is nothing but those many nodes, okay, starting from the root node to go to the leaf node. Tell me if I had to, I cannot have 1 here because this is just a non-leaf node, as mean it's a root node. But if you have to calculate the minimum depth starting from this node, I have to go where I have to go to a leaf node. Now the leaf nodes which are present in this tree are only 2, 15 and 7, right? So I have to find out the minimum depth between this path 320 and 15, or else the minimum between 320 and 7. So both 320 and 15 are how many nodes? 3 nodes here, and even for this part there is 3 nodes. So what actually should have been my answer? 3 and not 1. But that means using this logic, okay, my all test cases are not going to give me correct answer. Do you understand? Yes, it works for this, but it does not work for this scenario. Okay, so that means this logic is flawed and we cannot use this logic, right? I hope this makes sense. Now let's understand why did, let's say this is tree 1 and this is tree 2. Let's understand why did this logic failed for tree 2. What was something different from it is from T1. Okay, can I say if there is a left child, okay, and there is also a right child, all right, if this is the case, can I say then you can apply the formula 1 plus minimum of whatever your left height it is and right height. Can I do that? Yes, think about this. This is what you're actually, that is this, because of this condition, this tree was giving a correct answer. If you look at this tree, when you are trying to calculate the minimum depth, looking at the root node, there was a left child and there was also a right child, correct? And that's why we applied this formula 1 plus minimum of left comma root, and it worked and we had got a correct, minimum depth for this tree. But look at here. Is there a left child? No. So if you have only one child, like it's a binary tree, means you will have at most 2 children. So if you have only one child, what you should be returning is, you should be returning 1 plus. Suppose if you have only the left child, if left child exists, so you're going to return the minimum depth will be 1 plus whatever the depth height of at the left subtree. Let's say if only right tree subtree exists, or only right child is present, you're going to return 1 plus right. Yes, so see, if I had used this condition, look at this in this place, okay, here, what is this? This is 0, right? This was what? 2. But what is this? This particular root does not have both left and right child. So this condition I cannot apply. It basically falls in this condition where I only have the right child. When you only have the right child, I have to use the formula 1 plus whatever the height was there on the right subtree. So 1 plus 2, right? This was the height, will give me what? 3. And that is what would be the minimum depth for this question. I hope you get this, right? So this just applying 1 plus minimum of left and root is not going to work for all test cases. It might work when you have a node which has both left and right child. But if you have a tree in where you can have a node which does not have both left and right, it can have only one of the child. In that case, you have to return what? 1 plus whatever child is available. Okay, I hope this makes sense. So now then the code becomes very easy, correct? Now if you remember, here also we have all that, tree node. You can simply, I'm just simply removing this. So what I'm going to do is, first thing, but as for everything remains the same, right? What we had, if root is equal to null, I could have simply return 0. Yes, that's always going to be return 0. Then I'm going to say int left equal to min depth, right? And you're going to call root dot left. Okay, then you have int right equal to mean depth of root dot right. Now what we said, if both left and right child existed, then we could return 1 plus minimum of left and right. How do you check that? If both left and right child existed, that means left is not equal to 0 and right is also not equal to 0. Why? Because if left child was, there was no left child, so obviously when you returned, you would have, called a function on mean depth on a null value. And when it is a null value, you are returning what? The value as 0. Correct? So just to check whether there is a left child or a right child, you can simply, use a condition. If left is not equal to 0 and right is not equal to 0, that means there was a left and right child for this root. If that was the case, then I could simply use the formula which is going to be return 1 plus math dot minimum of, left and right. Okay, right? But let's say if this is not the case. So if this if condition is not true, that means if you're coming to line number 15, that means that that particular tree or particular root does not have, it has only one child, either it's left or right. How do you find out? You can simply say 1 plus math dot max of, math dot max of left comma right. And why will this work? This will work because, think about this, if let's say, suppose you had only, the left child existed and right child was null, right? Because it is null, the right value would be 0, correct? So a maximum of a left value, which is a positive number, right? It can be 2, 3, any number of nodes, comma 0 is going to return what? 1 plus maximum of 3 and 0 is 3. So what will you return? 1 plus 3. Correct? Is it as good as saying that whenever there is right child is not there, you are just adding 1 plus left? Correct? Let's say now your right child exists and your left child does not exist. If left child not exists, what is going to happen? Because of this condition, it's going to return 0 and your int left is going to have a value of 0. That means again, when you come down here, math dot maximum of 0 comma some right value, which will be a positive number. So 0 comma some positive number, what is the maximum? Always the positive number. So it's as good as saying 1 plus right. So this is like a shortcut. Okay, I hope you got this. So if I now, just simply submit this, it should work exactly fine. Okay, so I hope you understand this, right? And don't be disheartened if in case you were not able to figure out this question on your own, that why, how did I come up with this condition? It's absolutely normal, right? If you see my submissions also, there were certain times I have done, wrong answers. So it's a part and parcel of your coding journey. It is absolutely fine. You're learning as long as you understand why each line of the code is written. Okay, once you go through some solved examples, you will be good to go. Your logic will improve, and finally you will be reach a stage where you are able to come up with the solutions for a question on your own. Okay, hope this helps. Bye, take care.